Hello everybody. In this video we're going to talk about addition of vectors. So without wasting any time, let's get into it. So let's learn how do we add scalars first. Let's see, I have this box. It's a hollow box of 10 kgs. If I need to add a 5 kg box to this, let's say I'm keeping my 5 kg box on top of it to the right. So the net weight would be 15 kgs. That's fine. If I keep that box here, then the net weight is also 15 kgs. But what if I keep my box inside? It's again 15 kgs, right? Am I kidding or what? So mass is a scalar. We can add mass or subtract mass like arithmetic. So we can use simply addition or subtraction on scalars to add or subtract them. But this is not the case with vectors. For example, this is the box and I need to push this box. Let's say I have applied F1 force of 10 newtons and my friend also applying F2 force of 5 newtons in the east direction. What's the net force applied? Would be 10 plus 5, 15 newtons east. The box will move ultimately in east. But what if the same box, I am applying the force of 10 newtons in east and my friend is applying 5 newtons in west? Now what's the net force? Can I simply say the net force is 15? No. Now the net force is 10 minus 5. That's 5 newtons. But ultimately, the box will be moving in east because I am applying more force into the east. So if I add vectors, it will give me 15. Here it's giving me 5. Because vectors have direction, that's why we cannot just simply add or subtract. We can simply add or subtract them in some cases. What are those cases? Let's write special cases. First one is when both the vectors are in exact same direction, you can simply add them. And when the force is when two forces are exactly opposite, you can simply subtract them. So in only these two cases, you can simply add or subtract the vectors, but simply add them and write the direction as well, because simply adding them will give you the magnitude. Vector is a complete information when you add a direction to it. So magnitude and direction will give you a vector quantity. Similarly, when you subtract them, you have to add a direction as well, right? Now, what are the methods by which I can add vectors? There are two methods. First is graphical method and other method is called analytical method. So in this video, we're going to talk about graphical method. What does the graphical method say? For example, I have two forces or two vectors, A and B. If I need to add A and B, I need to find what is my A plus B. So simply just draw a A vector, draw a B vector on the head of A vector. What's the head of A vector? this is my head of A vector, and this is tail of A vector. So keep B vector on the head of A vector. We have B vector on the head of A vector. So the third side completing the triangle is called the addition or the resultant of A and B. So there are two possibilities to complete a third side. Either from the head of B to uh, tail of A, or from tail of A to head of B. So you have to complete the triangle side from the tail of A, right? So this is my triangle. So this is called A plus B vector, or the resultant of A and B. Why? Because instead of applying A and B to separate vectors, I can just apply that resultant vector A plus B to get the same effect as A and B both. So in this scenario, a triangle is formed. So this method is called triangle law of vector addition. So this is the first method. What if I keep my B vector on the tail of A vector? In this method, I kept my B vector on the head of A vector. But if I keep my B vector on the tail of A vector, then let's complete this figure, this parallelogram, and the diagonal of the parallelogram would give me my A plus B, or the resultant vector of A and B. So in this scenario, a parallelogram is formed. That's why it's called parallelogram of vector addition. Now that's A plus B. That will give you the magnitude. In this case also, that will give you the magnitude. How do we calculate the direction of this vector? Direction is given by the angle. In this case, this would be the direction, and in the second case, this would be my direction. So how would you calculate the direction of the resultant vector in these two cases? So in the triangle law, just draw a perpendicular like this. This is my perpendicular and this is my right angle triangle. So how can I find the angle theta in that right angle triangle? Let's say this is my y1 and this is x1. So you can write a tangent theta equal y1 over x1, and theta equals to tan inverse y1 over x1. That will give you the direction of A plus B vector, right? And in this case also, you'll draw a perpendicular. So this is again your y1 and this is again your x1. You can write tangent theta in this right angle triangle, and that is y1 over x1, and your theta is given by tangent inverse y1 over x1. So till now we have learned when we have two vectors. What if we have more than two vectors? How do we add them? For example, this is my A vector, this is my B vector, this is my C vector, this is my D vector. I have learned how to add two vectors, but how do we add more than two vectors? By the graphical method. So let's just draw these vectors from head to tail, head to tail. So write down A vector, head to tail. So on top of head of A vectors, place B vector. Then on the head of B vector, place C vector. On the head of C vector, place D vector. And the side left of the polygon, this left, To complete the polygon, the side left is called your resultant, and that resultant is A plus B plus C plus D. And you can calculate the direction as well, similar method. So this method is called polygon law of vector addition. Right, so we have added our vectors by 3 graphical methods. First one is triangle law, second is parallelogram law, and third is polygon law. And they are clear from their names. In triangle law, a triangle is formed. In parallelogram law, a parallelogram is formed. In polygon law, a polygon is formed of side more than 4, basically. So it can be anything, a pentagon, hexagon, octagon, more than that, right? Depending on the number of vectors you have. So yeah, that's it for this video. I'll see you guys in the next one.